All right, so we've got the bullet, and now this is one of the ones where we work backwards, right? So again, let's draw our requisite three pictures, right? This is the order it happens, right? Bullet strikes block. It's hanging on the strings, right? The bullet sticks in the block, right? And so here the bullet's moving, the block is sitting still. Here they're both moving at a more stately pace, right? And then in the last picture, they have swung up to some height. And we know that this height is 0.426 meters, okay? And then what we do, in this collision, momentum is conserved. In this swinging up, energy is conserved. So when we work this thing backwards, the first thing we'll do is we'll say, okay, the 1/2 mv squared that we had here came from the mgh, right? So let's fill this in, right? Let's figure out let's add the bullet mass, 125, plus 1.625. So 0.0125 plus 1.625 is 1.6375 kilograms. That's the block mass with the bullet added onto it, right? So turn these into kilograms. That's always the safest thing to do, right? And then let's just solve this thing, right? So 1/2 1.6375 times v squared equals 1.6375 times 9.81 times 0.426, right? So potential turns to kinetic, or potential came from kinetic, right? Okay, notice that the mass cancels, so I don't even need that, right? So I'm going to solve this thing. I'm going to go, square root of 2 times 9.81 times 0.426. Okay. And I get that this velocity here, this thing here is, the velocity is 2.891 meters per second, right? Okay. Now I need to work backwards. So let's do the momentum layer here, right? Okay, so I've got 0.0125 going some velocity here. I'm looking at this picture, right? It's going, we don't know that velocity, right? The block is not moving, right? That equals the bullet in the block, which is 1.6375. And here we do need the mass of the block and the bullet, right? And then it's going 2.89104, et cetera, et cetera. I'll just use that whole number, right? Okay, so the momentum of the bullet and block comes from just the momentum of the bullet, right? So I'm going to take that number, go 1 times 1.6375, right, and then divide by 0.0125, and I should get that velocity, which is 378.726 meters per second, which the velocity would be about 379 meters per second, okay? So again, draw your pictures. Remember, in the bullet striking the block, momentum is conserved, but kinetic energy is not, right? And then when it swings up to some height, kinetic becomes potential.